Hello, everyone. Welcome to the DI 101 webinar series. This is the very first installment of this new series, and it is being offered exclusively to our DI associates for this first installment. Future webinars will be targeting our valued customers, but we wanted to pilot this series with a special presentation just for our associates. For this pilot, we partnered with one of our largest and most valued manufacturing partners, Johns Manville. Experts from JM will be presenting on industrial and mechanical insulation products. While future webinars will be for external customers, we will be recording every webinar so that we can make it available to our associates for training purposes. So keep an eye out for those future announcements on when those are posted. We will pause for questions at the halfway point of the webinar, and then we will pause again, open again for questions at the end. To submit questions, please use the questions tab on the GoToWebinar panel. You can submit your questions at any point during the webinar, and we will answer the questions during those two question periods that I mentioned earlier. Without further delay, I will turn this over to Kim Melton, Senior Marketing Specialist with Johns Manville.
Thanks, Jared, and thank you for the opportunity to pilot and launch this program with you guys. My name is Kim Melton, and I am, as Jared said, the Senior Marketing Specialist. I'll be going over a couple resources we have at the end of the presentation. Joining me today are Jack Bittner and Lance Bonin, who are going to kick things off. Lance, go ahead.
So I'm Lance Bonin. I am the portfolio manager for the mechanical insulations at Johns Manville. Been with JM for 19 years, and in glass industry in general, about 25 years. Email is listed there, so if you have questions you think of after the webinar, feel free to reach out, and I'll be covering my products in the second half of the webinar.
I'm Jack Bittner. I'm the Senior Product Manager for all the industrial materials JM makes. I've been around the industrial insulation business for 35 years, 15 of them with Johns Manville. I serve on a couple of associations, the NAMA C&I committee. I'm the chairman. I'm also on the board of directors for NIA, and my email address is there too. So let's get started. I'm going to open talking about the industrial insulation materials. I'll start with reasons to insulate, and these are true for both Lance's products as well as mine. However, on the industrial side, the two reasons to insulate at the top are really paramount. Process control on the in the refining and petrochemical side is primary, and secondarily is personnel protection. The others follow, but those are the two primary reasons folks insulate. There's also a number of reasons folks insulate, and they're all listed there on the left side, and they all don't have equal importance. And the relative importance changes depending on the application, where it is, how low to the ground is it up in a pipe rack, is it near vibration? So not everything is a 10 and not everything is a 1 every time. It all depends. And we have a tool that's on our website, that product application rating tool on the right side, that helps you or your customer select the right insulation for the job, because the reasons you're insulating change with the application. So that's just a heads up there. And that's also the reason why we have so many different products on the industrial side. If there was one product that did everything, man, we'd have it, but there is no silver bullet. So we have various materials because there is no one single product that will serve every single application. So we have to have a number of products because that's simply the way it is. So this this slide here is a chart that really illustrates all the, well, not all, but pretty much all the industrial insulation materials available on the market today, from the cryogenics to the hot, and the top 5: calcium, perlite, mineral wool, fiberglass, also, and hydrophobic microporous blankets. Those 5 materials JM supplies in one form or another. And you can see we're not in the cryo side of the business. We are focused on the hot insulation products. So the products we offer are listed here: perlite, calcium, microporous blanket. various shapes and sizes of mineral wool, and we also have some accessory products, glues and cements. So let's start with calcium silicate. Thermo 1200 is our flagship product. We've been in the calcium silicate business for more than 40 years, and we have two factories, Ruston, Louisiana, and Fruita, Colorado. The advantages of calcium silicate, honestly, historically, the greatest strength of calcium silicate has been its strength, its compressive strength. It's the strongest material on the market today as far as being able to take a beating, to be stood on, walked on, which you're not supposed to do, of course, but everybody seems to do. And its other advantages are it's been consistent thermal performance. And the way you get consistent thermal performance is from compressive strength. If you don't reduce the thickness by squeezing it or compressing it, you will maintain consistent thermal performance. Recently, we've added other advantages, a corrosion inhibitor, and also most recently, we've made it water resistant. This slide's pretty much a summary of what I've already talked about. Probably the only thing two things I haven't mentioned here is all of our industrial insulation products are rated to 1200 degrees, and the density of a Thermo 1200 is 14 pounds per cubic foot. The most recent feature we've added is water resistance. I know this slide's probably hard for you guys to read, but what we've done is that the legacy product, which we're calling Thermo 12 Gold, which we used to make, would absorb water like a sponge. It would, if it rained, you didn't see water dripping off of Thermo 12, it sucked it right up. This new product is water resistant. It was designed to withstand a rainstorm. The whole thing was a contractor play. The insulators could always insulate a pipe faster than the metal jacketing guys can come behind them and install the jacketing. So on the, particularly in the Gulf Coast, the afternoon comes, you get that 2 o'clock rainstorm, and the insulators are way down, far ahead of the jacket guys, and now this mad scramble starts when the rain comes to put visqueen over it so it doesn't get wet. Job stops. It's a productivity problem. So we've made it water resistant so it'll withstand a moderate rainstorm for up to 20 minutes and absorb less than 15% water, where prior to making it water resistant, it would absorb 88% water, which is what that first bar chart or bar shows. So this was a really a significant advantage, and it actually was designed for the contractors, but what we found is the engineers like it way more than I thought, and they're actually specifying water resistant Thermo 12. The other significant advantage is this corrosion inhibitor, which is in our calcium silicate. And by the way, we don't make two calcils now. You can't order it without the corrosion inhibitor, and you cannot order it also without the water resistant. We only make one, and it comes water resistant with the corrosion inhibitor. We don't make the old style anymore. The corrosion inhibitor is integral to the product. And what it does, very, very simply, is it provides a buffering layer between the pipe and the insulation, which inhibits the corrosion from happening on the pipe. So we've got a whole 30-minute presentation that we can get into great detail on how this actually works. But very briefly, it provides a buffering layer between the insulation and the pipe, so it breaks the what's the word I'm looking for? It breaks the connection that you need for the water and the electrolytes to contact the pipe to allow corrosion to happen. And this corrosion inhibitor is there for the life of the insulation installation. So if the pipe's insulated with Thermo 1200 for 25 years, that's how long the corrosion inhibitor properties are there. It doesn't wear out, it doesn't wash out, it's there for the life of the system. These are pictures of some long-term testing we've done. You're going to see similar pictures throughout my presentation here because we've done it for calcium perlite and our Insulthin blanket, the same test. So these are long-term testing results. This is 600 cycles, hot, wet over a 6-month period. The whole point here, I'm not going to get into great detail, but the whole point on this test is with corrosion, what you're looking for is how deep the pit is, because that's reducing the wall thickness of the pipe. And the result is Thermo 1200 resulted in much substantially shallower pitting than in this case we tested against silica aerogel. So that's the key. That's what everybody's looking for. That's what all the end users are interested in, is the depth of the pit. So that's the big takeaway from this slide. Next product, expanded perlite, which is our sprue. And again, it's 1200 degrees upper temperature limit. Advantages are it's got the corrosion inhibitor. It's got very good compressive strength. Not as good as calcium silicate. This is 80 psi, where Thermo 1200 was 100. But this product is more than water resistant. It's hydrophobic. So it'll take more than a 20-minute rainstorm. You can leave it out overnight, 2 days, whatever. However, just so you know, we recommend installing weatherproof jacketing on every insulation we have, regardless of what it is and whether it's hydrophobic or not. But this perlite is hydrophobic. The summary, I've talked about most of this already. Historically, it's been installed through the years on stainless steel piping because it's always performed very well with stress corrosion cracking, mainly due to the fact that it has a corrosion inhibitor in it and it's hydrophobic, so it's always performed well there, although now it's specified extensively also on carbon steel pipes. Comparing calcium and perlite, one's hydrophobic, perlite, calcium is water resistant. You can see the compressive strength difference. The density is pretty close. The other difference is the calcium silicate has a lower, which means better, thermal conductivity than perlite. They're close, but calcium silicate's a little bit better. So depending on the operating temperature of the pipe, you might need 2 inches of calcium silicate and maybe 2.5 of perlite. Similar picture to what we just saw with Thermo 1200. Again, this is compared with silica aerogel, and the results were the same on this long-term testing. The pitting was much shallower, significantly shallower with perlite than we found with silica aerogel. And again, the pitch is the loss in wall thickness due to corrosion. Hydrophobic microporous blankets, that's a mouthful. We just call it Insulthin HT. This is a quilted blanket. It has fabric on both sides, so it's sewn together. Thin, flexible blankets are really ideal for where you have space constraints. They're expensive, so you may not necessarily want to use them everywhere wholesale, but where you've got pipes that are very close together and you don't have room for 2 inches or 3 inches of calcium or perlite or mineral wool, these thin blankets are absolutely ideal. They do have, or at least Insulthin has a very low CUI potential. It is hydrophobic, and the other advantages is their thermal conductivities are extremely low, which is one of their great advantages, and that's why you can get by with a very thin profile. It comes 5 millimeters thick in rolls and 10 millimeters thick. They're also ideal for hybrid systems, so if you don't want to incur a huge expense of maybe 3 or 4 layers of the thin blanket because of its cost, and you have room, you can do a hybrid with maybe an inner layer of the Insulthin and an outer layer of a traditional insulation like mineral wool or perlite or calcium. I've covered a lot of this. Compressive strength, you can see it there, 3.6 compared to calcium of 100. So but again, it's thin, and its compressive strength isn't that big of an issue typically. We don't put a corrosion inhibitor in it. However, it performs very well on the ASTM corrosion test. And it does not have, I want to point out this thermal shift, which we are about to talk about, I think. Nope, not yet. Next. Kim's laughing. This is the same kind of pipes. We did the same kind of long-term testing. Again, this was a 6-month test over 600 cycles, and much less corrosion overall compared to silica aerogel, and significantly less pitting. And again, pitting is the key, the depth of the wall loss. And again, if you guys want to see more on this, we've got several modules, presentation modules that our sales reps or technical managers could come in and give you guys over a lunch and learn that can get into greater detail on all of this CUI stuff. But this is just a tease right here. Here's thermal shift. What we found with silica aerogel, we test all our products for thermal conductivity. One nice thing about JM is we have this really nice technical lab, 350,000 square feet outside of Denver, full of PhDs and science guys. We test everything because it doesn't really cost us much. So when we get our products or competitive products, we test thermal conductivities because we have a thermal conductivity lab. So we found with aerogel, it doesn't happen with any other product we've ever tested, that after you cycle it up to the high temperature and down, and we're looking at the graph here on the left, and then up again, the thermal conductivity changed. It doesn't happen with any other product, whether it's calcium, perlite, mineral wool, insul thin, foam glass, anything else we ever tested. But the thermal conductivity changes by up to 20%. It gets a little bit worse. And we understand the science of that, but I'm running out of time, so I'll get into that on our next webinar. But it's legitimate. It happens. We've got outside testing that supports this, and it's unique to silica aerogel. So just so you know that. We've also done some dust and industrial hygiene tests on these thin blankets because they are made of granular materials, both aerogels and our microporous blankets. And the insul thin is the blue bar. And there's 2 types of aerogels available today in the market. So there's sample A and sample B. The respirable particulates are the ones where we had the monitor on the guy who was installing it on his collar. And the total particulates was the monitor that was above the work area, monitoring in the air. So it's evident that insul thin is much better when it comes to workplace dust. And finally, my mineral wool. Mineral wool is mineral wool, but we make it in all different kinds of shapes and sizes and forms. Mandrel wound pipe, which is the upper left. We also take board and we'll cut it into, on the V-groove machine, which we have in Houston, and turn it into V-groove preformed pipe insulation, field form, which is V-groove, but we ship it flat and it has glue in the joints, so you form it in the field. There's also precision cut, which is the middle row, far left, which is V-groove with no glue. And honestly, why anybody buys that, I'll never know. It's just more work to install it. We also make a pipe and tank wrap. We make a lamella pipe and tank wrap, and we make various boards, including a metal mesh blanket. It's all mineral wool, just different shapes, different forms. Mineral wool has several advantages. It's very good with acoustics. The V-groove material, if it is shipped flat, you'll see it in the job site stores, that middle picture on the top. What you're looking at there is 2 bills, the same bill of materials, 2 product forms. So shipped flat is a great advantage for filling trucks and also job site stores, taking up much less space. It's non-combustible, it's lightweight, its density a little more than half the weight of a calcium or a perlite. And our pipe insulation, as of the last month, is now water repellent. You can read this here. One thing, it does not have a corrosion inhibitor, so it does not perform as well as some of the other insulations in inhibiting corrosion. If we could figure out a way to put a corrosion inhibitor in mineral wool, believe me, we would. We just haven't figured that out yet. So that's one of its disadvantages. But its other advantages are it's got a great thermal conductivity, better than calcium perlite, so it's a better insulator. And it's a lot more lightweight. It doesn't have the compressive strength, which I think might be the next slide. No, binder. So one of the things mineral wool does have, because it's fibrous, it has an organic binder. Organic binder means at temperatures at 350 and above, it's going to start to burn out. The good news is the thermal conductivity doesn't change without the binder, but when the binder is not there, the binder is what holds the fibers together, so the compressive strength may be compromised. Also, on the in any environments where there's high vibration, where there's no binder holding the fibers together, the fibers will tend to settle, as you'll see in the picture on the right. So that pipe there is very well insulated on the bottom, but not so much on the top anymore. And that's because the binder's wasn't there to hold the fibers in the high vibration environment. And that's it.
We will open it up to questions. Jared,
Yes.
did any questions come through for the industrial portfolio?
Hello, yes, we do. This is from Sybil. She says, "What is the cloth made of for the Insulthin HT that it withstands 1,200 degrees Fahrenheit? Does this make
Hi,
the cloth?
Sybil.
Does this
I'm
make
sorry.
the cloth more friable? Is there an issue with the extended length of service that it will lose its coating, meaning the coating on the cloth?"
Okay. First, hi, Sybil. Hadn't talked to you in a while. First of all, the fabric is an E-glass fabric, so it will take the temperatures up to 1,200 degrees. There isn't a coating on it, so the E-glass is E-glass, so it'll be fine. What doesn't take the temperatures up to 1,200 degrees is the thread. So the thread will burn away. The product is not designed to be reused. It's a one-time use product for those high temperatures. And that's mainly due to the fact that the thread's going to burn out. But the fabric itself will take those temperatures.
Jack, can you speak a little bit to the hydrophobicity of the product that you
Yes.
asked about the coating?
Yes. The hydrophobicity is not a coating, but thanks for clarifying that, Kim. The hydrophobicity, anything that's hydrophobic is treated with an organic material to make it hydrophobic. All organics are going to oxidize or burn out starting at 350, 400 degrees, just like the binder in mineral wool. So nothing is going to remain hydrophobic beyond 400 degrees and up. And that's true for perlite, it's true for Insulthin, it'd be true for aerogel, it'll be true for our water-resistant mineral wool. It'll be true for the ID of the water-resistant calcil. Same thing with Insulthin. It's an organic.
Great. The next question is from Daniel. He says, "What is the difference in mineral wool lamella tank wrap and mineral wool pipe and tank wrap?"
The main difference is the orientation of the fibers. The mineral wool pipe and tank wrap we make in Phoenix City, so it's made with fibers that come off the line just like when we make a board. So they're oriented horizontal to the facer. Where a lamella is where you take boards, you stand them up on end like soldier course, and then if you need 2 inches of insulation, you run a saw blade. Can you go back to that picture, Kim? You can't really see it on the lamella. You run a saw blade and you cut them all off. The fibers essentially are oriented 90 degrees different than the pipe and tank wraps. So the fibers are standing up and down on the they're vertical, perpendicular on the facer, if I'm explaining that right.
Mm-hmm.
And so one of the downsides of lamella is the pipe and tank rack and lamella might be 8-pound density, but the thermal conductivity is going to be different, up to 20% different with lamella, simply due to the fiber orientation, where the heat can travel along the fibers on a straight line through to the cold face surface, where with the horizontally oriented fibers, the heat has to weave its way through, so you have a better insulation value with pipe and tank wrap, same density.
Great. And circling back to Sybil's question, she says, I had an engineer ask if this is a good alternative to the CalSil for fireproofing. I told them no.
She gave the right answer, and mainly because we have not tested it to UL 1709. So I have nothing to support that it would be.
Okay. Looks like we have another question from Susan. Why don't you add adhesive to precision cut mineral wool?
Because we have adhesive on field formed mineral wool. We would rather not make precision cut, but we have customers who actually want to order it. So that's the only reason we make it. Somebody wants it.
All right, I believe that's the last one for now. So, guys, if you have any questions, maybe some of you jumped in a little later. If you have a question, use the questions tab on the GoToWebinar panel, and we'll ask them during this session. I do have one more that just came in. What is the benefit of Insulthin versus Aspen Aerogel?
Couple benefits. Number one, there is no thermal shift. And ultimately what thermal shift means is you usually will need one or more layers of aerogel than you will for Insulthin, because Insulthin does not experience thermal shift. Secondly, Insulthin performs better on CUI than an Aspen aerogel, or really any aerogel product. Those are the two main reasons. So it's going to be cheaper to install. That's the other one. Three, really. Fewer layers, and that means less labor, so it's cheaper to install. And CUI performance is significantly better than aerogel.
To add to Jack's answer there, the industrial hygiene sampling has also indicated that Insulthin distributes significantly less dust, between 65 and 83% less dust during installations.
Thank you, Kim.
And one more as a follow-up. How does Insulthin compare to Armacel's new Armagel product?
I believe it's going to be similar to Aspen Aerogel. The only reason I say I believe is because we haven't been able to secure a roll of Armagel yet to do the extensive testing. If anybody has a roll, I'd love to get it. And we better let Lance go, or we're going to run out of time. I'll hang around till the end too, in case more questions come in.
All right, thanks, guys. No, that's the last one so far, so y'all can proceed. We'll answer the rest of the questions that come through at the end.
Okay, let's talk about the mechanical insulation products. So really, what are mechanical applications? These generally involve systems that are associated with movement. So it could be elevators and escalators, but for us more commonly, it's things like the plumbing systems and the heating and HVAC systems. So we're going to be insulating the equipment associated with those, and then the pipes and the ducts that move the fluids throughout the building. So this is going to be steam lines, chilled water lines, domestic hot and cold, things like that. In terms of commercial buildings, our products end up there a lot because there's large centralized mechanical systems within these buildings. You know, just some examples of them are offices, hospitals, hotels, schools, things like that. There are quite a few of them, but those are some of the more common. And then the mechanical insulation products can end up in some light industrial applications like food processing or pharmaceutical and marine as well. So we'll cover all of that. So from a design consideration standpoint, engineers are going to be thinking about things like the system, what is the ambient temperature that it'll be operating in, what are the relative humidity conditions, and what kind of surface temperatures need to be considered. So for a hot system, it's likely personnel protection, how much insulation given the system and the conditions of the air do we need to keep people safe, to make sure they're under the 130 degree general temperature range. Or for a chilled system, you have to make sure the surface temperature is above the dew point. In terms of fluid delivery, they're considering things like the length of the run, the velocity of the fluid moving through the system, and really where the end temperature needs to be when the fluid's delivered. So there are some tools that can help with this. NEMA has a program called 3E+. It's on their website that lets engineers calculate these kind of things. Or you can contact Johns Manville. We have it with our data loaded into the system, and we can help engineers do the calculations for their particular circumstances. And of course, spacing is critical. Obviously, Jack touched on it. If you lose thickness in insulation, you lose performance. So there has to be enough room to allow the insulation to not be compressed. So we're going to talk a lot about fiberglass insulations, but there are other types. Jack covered mineral wool and calcil. Both can end up in mechanical systems. There are quite a few different varieties of foam, things like elastomeric rubber with the black flexible style of insulation. There are polyisos we'll go a little bit into. And then there are some applications where you'll see cellular glass. Maybe you're looking for a incompressible material, zero perm, something like that would drive the demand for a cellular glass. So let's talk a little bit about fiberglass pipe and insulation boards. These products deliver on the temperature control, energy efficiency, and they do that by creating really small air pockets within the insulation. And these air pockets limit conduction and convection. And that's how really you're delivering that thermal performance. It's also the aspect that delivers the acoustical performance. So that system is going to absorb the sound waves and provide some acoustical benefits. With the help of a vapor retarder jacketing, you can also have condensation control. So with pipe insulation and boards, these come in a variety of pipe sizes and wall thicknesses. And for the boards, they come in densities and thicknesses that we'll go over in just a moment. So Johns Manville's pipe insulation is the Microlock HP line. There are two jackets associated with that. The Microlock HP is an ASJ jacket, which stands for All Service Jacket. That's a white bleached craft paper on the outside, scrim reinforcement, and then foil that faces the insulation, providing that vapor barrier. So this product has a perm rating of 0.02, low being better. So it does resist the flow of moisture quite readily and is considered a vapor barrier. Microlock HP Ultra is similar. The jacket, instead of being 3 layers, though, is 4. The outer layer is a polypropylene coating, and for Johns Manville products, that Ultra designates a polypropylene. And then it does have the traditional craft paper, scrim reinforcement, and a foil inlayer, giving you the perm rating. For this product, it's 0.01, so it's a little bit better at allowing for or preventing the drive of moisture. The product lines are good to 850 degrees, and they have good K values at 0.23. Again, low is better, and so it's quite good insulator. We do have an unjacketed version that's typically used in light industrial. It's the same as the other two products, but it just does not have a facing. So fiberglass boards come in a number of varieties. 800 series is the most common commercial application. It's good to 450 degrees. Comes in densities that are as light as 1.5 pounds and as heavy as 6 pounds. And generally, you're looking for a little bit better thermal performance with the heavier density products. Could be a little bit better acoustical performance as well with those heavier products. There are 3 jacket styles available for this product line. We have the FSK, which is a foil scrim craft. So in this case, the foil is facing out. That is what's giving you your vapor retarder at 0.02 perms. And it has a reinforcing scrim with a craft layer of paper facing the product. Also comes in ASJ, which is similar to Microlock HP, same arrangement. And we do have an Ultra version for spin glass, but in this particular case, the Ultra does signify polypropylene, but there is no paper in this. It does have this scrim reinforcing layer, and it's got a metallized polyester, so it doesn't use a foam to create its vapor barrier. But it has similar performance at 0.02 perm, so a good vapor retarder. 1000 series and precip are light industrial fiberglass board products, good up to 850 degrees. The main difference is their densities. 1000 series is 3 pound, precip is 2.4. The precip then, is a little bit more of an advantage if you've got an irregular shape or a large tank. You can bend this insulation slightly and conform to that shape. And then we do make a fabrication board. For us, we are just a supplier of the fiberglass insulation. We do not make that segmented pipe and tank that Jack was talking about. This is going to be done fabricated somewhere close to the point of use, and it could be fabricated in one of your locations. That's all I would say on those, Kim. So let's talk about polyiso foam board. We do have a polyiso insulation. It has the same thermal performance and energy efficiency attributes that fiberglass does. It is, however, a little bit better insulator. It's got a K value of 0.17, so better than fiberglass, which is at 0.23. It's very lightweight and has a high compressive strength when compared to fiberglass. We'll talk about that in just a moment. And it is a closed cell insulation, so it does inhibit the intrusion of moisture. The product line for us is Expect IsoFoam APF. It is a polyiso board with 2 jackets. Both are a foil jacket on top and bottom. The thicknesses range from 1 inch to 4 inch. It gives you an R range from R6 to R26. The surface temperature range also goes lower than fiberglass at -100 F, but it's limited to 250 on the hot side. The biggest drawback to this product line is going to be in its flame and smoke development. Flame is pretty good at 25, but it will smoke in a combustion setting. So it has a rating of 450. So often inside of a commercial building, you're going to see a spec that calls for 2550, which would then exclude this product. So typical applications for us is going to be a rooftop application. That flame and smoke development issue is generally not a concern on an exterior of a building. Of course, the local code body has the authority there to make that decision. But when they allow it, polyiso is a very good rooftop duct. For OEM applications, it could be in appliances or equipment. Generally here you're trying to take advantage of the very good thermal performance to reduce the need for space that's dedicated to insulation. So let's talk about the fiberglass board and blankets. So these are generally used in situations where you need some flexibility from the insulation. It's going to be used on large round tanks. There are some products that are used in removable blankets and pads, and it delivers the same kind of performance that the insulations we've been talking about. One feature that's a little bit different we'll talk about in the duct wraps is the product can be provided in a formaldehyde-free version. So our pipe and tank insulation is called Microflex. It comes in 2 different facings. It's FSK and ASJ, so I already talked about those. It's the same configuration as the boards. This product is board-like in its compressive strength, but it, because of the fiber orientation, does allow for some flexibility on large pipe and tanks. So that is what makes Microflex unique. HCB26 is a very high temperature fiberglass product, up to 1,000 degrees. It's most often used in some sort of removable pad. It does have a Coast Guard designation to it, so it could have some marine applications as well. For duct wrap, we have 3 facing varieties. The primary product line is Microlite FSK. So again, it's that foil scrim craft style facing. Comes in densities that range from 3/4 pound to 1.5 pounds, which drives your K value better, performance, a little bit better insulation with a little bit higher density. And it has a good perm rating coming from the FSK of 0.02. If you have a application that's going to be exposed and there's high sensitivity to the aesthetics, we have a couple of facings that might work in those situations. We have a white PSK, and we're about to launch a black version of PSK. So that is coming here yet this year. They have very similar performance to the Microlite FSK in terms of thermal, but for those areas that require a certain look, these PSK facings are going to be what your engineers may be looking for. In terms of marine insulation, here we're going to be insulating commercial or military vessels, could be an oil drilling rig, something along those lines. And it's providing the same kind of features that all the other insulations that we've discussed, temperature control, acoustic control. But a unique feature of marine products is they're generally considered incombustible, as fire is quite a large concern in marine applications. So we have 3 marine insulations: incombustible whole board, which is what it sounds like. It is a board used in the hull of the ship. For us, we are, again, just the insulation supplier. We have several DI locations that do this work in terms of providing the finished product. They're going to put some sort of facer on these insulations, and it's really that composite that meets the Coast Guard requirements or the specific ship requirements. So it's always in partnership with a fabricator when our products are used. We also have a light density product. Incombustible microlite could be used in like the HVAC systems of the ship. And we have mineral wool as well that can be used, higher temperature, quite good acoustically at low frequencies in particular. And that's all I would say about those. Talk a little bit about our PVC systems. Here, as opposed to insulation where you're looking for thermal and acoustical performance, here we're talking more about ways to increase the resistance to abuse, or it's likely some sort of aesthetic component you're trying to address. These are very good looking systems when they're installed, and color in particular can be used to identify the materials that are flowing through the pipes. PVC also is considered a vapor barrier. It has a perm rating below 1, so it can contribute positively to condensation control. And the white PVC does have some UV resistance to it, which allows it to be used outside. For JM, we have 2 primary styles of PVC fittings. We have the 2000 series, which is your commercial grade. It's nominally 20 mils thick, and it comes in white or a variety of colors up to 13. Zeston 300 is considered a heavier gauge. It's nominally 30 mil. It's going to be used in those high abuse areas, or maybe in a USDA wash down setting where they're going to, like in a food processing plant, want to wash down their own systems. And these 300 series fittings can stand up to that. There's also a jacketing system for us. It's cut and curl jacketing. It comes in the 20 and 30 mils. It matches the colors from the fittings as well, 3 or 4 feet in length. And it, again, could be used in that high abuse setting if purchased in the 30 mil thickness. One of the things that can be challenging for somebody new is just sizing up the right fitting for the application. So here we've got a picture of our sizing chart. On the left-hand column, you have pipe insulation IDs, and then on the top row, you have insulation thicknesses. So here we've got a 4x1, so you got 4-inch on the the ID and 1 inch in the wall thickness. And where those two rows and columns meet, you see it's a number 15, and that's how you would identify the right size for that application. And the reason we do that is because the fittings will fit a number of different combinations. So when you buy a 15, it will work for 3 or 4 different combinations, so it adds to the versatility of the product line. There are styles of pipe connections that are called mechanical groove type. They're a little bit bigger than sweat-in or welded pipes. Here, what we do is we make our fittings with a step to them. So if you look at the ends of those pictures, you can see how they get, kind of stepping up or gets a little bit progressively bigger. In this particular case, you just order, in that same 4-inch example, where you're trying to do an MGT 4x1, you just order the 4-inch because that'll fit all 4 sizes from 4x1/2 up to 4x2. 300 series, the heavier gauge, is similar to 2000 series. You identify the size in the same way, but here you're just designating the outside diameter. In this particular case, it's 6.5 300 series fitting that you'd be looking for. In terms of the product offering, we have a PVC fitting, likely for most any type of situation you run into. There's something well over 2,000 combinations that we have a fitting for. It ranges from elbows, T's, couplings, Y branches. If you run into something you're not sure if we have it, reach out to us. We'll let you know what we would have. We do have a couple new products that's really driven by code changes that were coming through. The IEC, the International Energy Code Commission, has determined that for those locations that are in the northern portions of the United States and outside of the building envelope or a conditioned space, they're calling for an R12 insulation now. And this is, again, for commercial buildings. So in those particular settings, you do need insulations that can meet a R code requirement. We've got 3 new products specifically for this code. We talked about Expect, that's R12 at 2 inches. We also have Duck Wrap, which is a Type 75 or 3/4 pound insulation at 4.4 inches thick. That is an R12 compliant duck wrap. And we didn't really talk about it today, but there are insulations that go inside of the ducts. Line Acoustic RC, that's a 3-inch product that also complies with an R12 rating. So Kim, I'll turn it over to you to talk about our training tools and then field questions.
Excellent. Thanks, Lance. So we offer webinars just like this one today about broader topics that talk a little bit less about our product specifically and more about main issues that impact the industry. And so Jack talked a lot about thermal shift and CUI. Lance talked a lot about condensation control. We, every month or so, we host a new webinar that covers topics like these. And we host these webinars on demand on the source. So if you missed the live webinar, you can actually go back and you can view them online on the source. Now, the source, what you see here on the left, it actually has our webinars are recorded, our blogs, documents, and documentation that might be helpful for technical questions you may have. A list of our products. This is pretty handy for anybody who's just learning what we offer. It basically is a short 1-sentence description of what our product is and what makes it unique to that product. So, for example, if you're looking for the difference between Microlock HP and Microlock HP Ultra, you'll be able to see that Ultra has that polytop coating. And then additionally, tools. Lance mentioned the NEMA 3E Plus tool. That's available online. We have the part tool that you saw in Jack's presentation, and that is that's also available on the source. And then finally, we have online training, and that's this is a great tool for anybody who's looking to get their feet wet. Is the JM Academy, and basically this will give you an introduction to our HVAC and mechanical installations, details about what you need to know to specify and install the material, and then additional information for, we have a couple details on like the proven safety of fiberglass. So it goes through the research of the health and safety of fiberglass installation. So if you're looking for more information, or if you have questions, or if you want more online training, these tools are all available to you, and you can access them on our website. So with that, Jared, we'd like to go ahead and open it back up to questions.
Thank you, guys. And I just want to take this opportunity to thank you, Kim, and all the team there at JM. I know, when we talked about this, just so all the attendees know, we know that we have some seasoned industry veterans in the group, but we also have some that are brand new to the industry. And so the goal was to try to have content on this webinar that would provide a little something for everyone, so that maybe everybody could pick up a nugget or two of information and insight into JM's product offerings. So thank you guys from JM, and we really appreciate it. We have a couple of questions. We have one from Susan. She says, are you working on getting fiberglass temperature up to 1,000 degrees like your competitor?
It's under consideration, and I'd be very curious to know, Susan, what market you're in. But it is definitely under consideration. Today, if you had a situation where you needed a letter, we would actually write a letter back and say that we could go to at least 950 degrees with a heat up schedule. So it's not generally published for us. We actually think mineral wool or calcil, something like that at those temperatures, is the better application. But if you run into something where the spec is, can't be changed, we will write a letter and say, follow this heat up schedule, and the product will perform up to 950 on the operating system.
Thanks. Hey, Kim, while I'm thinking about it, could you put the email addresses for the presenters in the chat box there for everyone, just in case they think of any questions like that? If Susan wants to reach out and elaborate on, I think that'd be great.
Yeah, absolutely.
Another question we have from Chad: is there any plan to make the JM Ultra a standard instead of a premium product? OC has a similar product as JM Ultra, and it is their standard product.
Yeah, and that's a good question. I would say that, anything around pricing, we really answer those locally. That's a question really for your MDM. I mean, our intent is to keep our distributors competitive in the situations that you're facing. So I would just take that issue to your market development manager, your outside sales rep from JM, and work with them on that issue. So for what it's worth, it is a more expensive facing. There is 4 layers to it versus 3, but I understand what you're saying in terms of about our competitors only offering one jacket. And, again, it is our intention to keep you guys competitive. So that's about all I can say on that in a webinar format.
Great. Another question from Early Wilkins. Is .030 PVC jacketing and fittings recommended for all USDA use, or is .020 acceptable?
I believe in terms of the claims we make, we always make it under the 30 mil fitting. And that's our standard claim on that. I don't know that we've ever authorized 020. We'll jot that down for a follow-up on that, but I just want to be 100% on that.
Okay. And Kim, I've gotten a few questions on getting the slides. Just so everybody knows, again, we are recording this entire webinar, and we will make that available on the huddle and distribute a link to this in video form. So that will be available. But Kim, I don't remember if we discussed this. Will you be able to send me the slide deck for internal distribution here as well?
I believe I can do that. And also, Jared, I actually don't have permissions to chat to the entire audience, so I couldn't send those email links directly to the audience. But yeah, I believe that'll be okay. Let me confirm. But I'm fairly certain that they would be all right with us distributing it to you guys to use internally.
Perfect. Give a couple, a minute or so, just to see if there are any other questions. I'm posting the email addresses to Lance, Jack, and Kim in the chat box in case any of you want to reach out to them for further discussion.
And to be clear for the audience, Lance would be for your mechanical questions, Jack would be for your industrial questions, and you can hit me with anything that falls in between, and I will distribute to the appropriate people.
All right, I think that's it. Nothing else is coming through. Thank you guys again. Thanks to all of our attendees for taking time out of your day. I hope you found this beneficial, and thanks to the team at Johns Manville for taking their time to do this for us. We really appreciate it.
Thank you for having us. We had a good time.
Thanks. Thanks, guys.
Have a great afternoon.
Bye-bye.